Okay, let's work through the calculus test review, starting with some Riemann sums. And you're going to be allowed to use a calculator and round decimals to the thousandth on this portion. So our function is going to be, for number one, x cubed plus x. And I want to use a left-hand Riemann sum with three subdivisions to get the area from 0 to 3. So if I'm going from 0 to 3, my delta x would be 3 minus 0 divided by the number of subdivisions, which is just 1. So we're going to step up by ones. And if you want the visual for the rectangles, there's going to be a rectangle going from 0 to 1, another one from 1 to 2, and another one from 2 to 3. And I'm going to determine the height of these rectangles by looking at the left-hand side. So my height will be at 0, at 1, and at 2. So for number 1, a right-handed Riemann sum with three subdivisions would be, I'm going to take my height of my rectangles out. My height is 1, and then I need to add up the function at height at 0, 1, and 2. And here is where the calculator will come in handy. We have 1 times f of 0. Well, you don't need a calculator for this one. F of 0 is 0. F of 1, 1 cubed plus 1 is 2. 2 cubed plus 2 is 10. And we have 1 times 2 plus 10, which gives you an answer of 12 for number 1. So number 2, my function is going to be the absolute value of 2x minus 3. And we're using a right-handed Riemann sum this time with 4 subdivisions to go from 1 to 5. So my delta x is going to be 5 minus 1 divided by the number of subdivisions, which again is 1. So I'm starting at 1, I'm increasing by 1 each time. So 1 to 2 to 3 to 4 to 5. And for the height of my rectangles, whoa, that was a bad rectangle. We'll look at the right-hand side. So right-hand Riemann sum. So my first rectangle height is going to be at 2. My next one's going to be at 3. My next one's going to be at 4. And my last one's going to be at 5. So as I set this up, my right-hand Riemann sum with 4 subdivisions is, the base of all my rectangles is 1, so I'm going to factor out the base, and the heights are my function's value at 2, 3, 4, and 5. And then we plug those values into my function up here to get the rectangle heights. And you get 1, 3, 5, and 7, and those add up to 16 times 1, and there's your answer for a right-handed Riemann sum. And 4 subdivisions for that function on that interval. And I think I made an error on number 1. Not an error, but this is a left-hand Riemann sum, so I should have written L3 for a left-hand Riemann sum instead of R3, which would indicate a right-hand Riemann sum. Let's see, so number 3, using a midpoint going from 1 to 7 with 3 subdivisions. So I'm going to start by finding my delta x. 7 minus 1 divided by 3 is going to give me a delta x of 2. And so I'm going from 1 and I'm increasing by 2 each time. So I'm going to go to 3, then 5, then 7. And my rectangles are going to go from 1 to 3, from 3 to 5, and then from 5 to 7. And I'm going to determine the height of my rectangles at the middle of each of these intervals. So I'm going to need 2, 4, and 6 to determine the heights of my rectangles. My function is x squared minus 1. And then my midpoint with 3 subdivisions would be my delta x is 2. I'm going to factor that out. And my function heights are my function values at 2, 4, and 6. And then we'll plug those into the calculator to get the individual heights. And then we'll multiply that sum by 2. Alright, so we get an answer of 106 for this one. Number 4, this one's finally the first one that's really ugly, and the calculator is going to come in handy. We're going from 1 to 7 with 6 subdivisions, so my delta x is not going to be too bad. It's going to be 7 minus 1 over 6, which gives me a delta x of 1. The thing is, we're doing a trapezoidal approximation, so on my x-axis, as I break up this interval, it's going to go from 1 to 2, all the way up to 7. And then your trapezoidal approximation, you have to remember, is the formula is your delta x over 2 times 1 of your first function value, so f of 1, and then 2, 3, 4, 5, and 6, all the numbers that are between the two endpoints, we have 2 of those. F of 2 plus 2, f of 3 plus 2, f of 4, and so on and so forth. And then at the very end, you have to remember that it's only one of the right endpoints. So you only have one of the 1 and the 7. And then everything in the middle, from 2 to 6, for trapezoidal rule, we have 2 of each of those. And here I'm going to go to the calculator, and this is the first time that rounding to the thousandth will come into play, because I'm going to need to find 2 plus the sine of 1, and 2 plus the sine of 2, and 2 plus the sine of 3, which are going to give me some pretty bad, funky-looking decimals. Make sure your calculator is in radians for this problem, and I'm going to get all those values and write them down real quick. There we go. There's our final answer. So I wrote down all the values of f of 2, f of 3, f of 4, f of 5, f of 6, f of 7, right there, multiplied them, and you should get around 11.805. I do want you to round to the third decimal, but because of rounding preferences up here, we might be off by a few 1,000ths, so you should be in that ballpark, but not too far away. All right, number 5 and 6, we are answering questions off of a table. And these problems, you're not going to be able to have a consistent delta x. We're doing area from 0 to 10, and I do want to use a left-hand Riemann sum with 4 subdivisions. But if we tried to do the delta x for 0 to 10, it would be 10 minus 0 divided by 4, which gives you a delta x of 2.5. And I don't have the information to be able to break this up into lengths of 2.5. So we're forced to use the information indicated by the table, and it says that right here, indicated by the table. So we have to take our first interval to go from 0 to 2. My next interval will go from 2 to 3, then from 5 to 6, and then from 6 to 7. And so my left-hand Riemann sum with 4 subdivisions, wrote in Oregon. Left-hand Riemann sum with 4 subdivisions. My first rectangle goes from 0 to 2, so the base of that rectangle would be 2. That's my change in x. And the height, we're going to determine the height by the left-hand side of each interval. So from 0 to 2, the function's value on the left side, go away, is 1. So it's going to be 2 times 1. Plus my next rectangle from 2 to 5, that's a delta x of 3. And the height on the left side is 4. So 3 times 4 plus from 5 to 6 is 1. Then we use 7. So 1 times 7 plus, and then last from 6 to 10 is 4, and the height at the left endpoint is 2, so 4 times 2. Then we'll multiply all that out. That's 2 plus 12 plus 7 plus 8, which is 29. So there's our answer for the left-hand Riemann sum with that table. And then I'm going to use the exact same table to estimate the same error, but on the next one, we're going to use the trapezoidal approximation. And again, because we do not have a consistent delta x, we can't use that formula that we used on number 4 just a minute ago. We have to break this up into 4 separate trapezoids. So to find the area of each individual trapezoid, you need to know that the area of a trapezoid is 1/2 the height times the sum of the bases. And the height of each trapezoid is the delta x. So my heights are 2, 3, 1, and 4. The bases are going to be the function values on each interval. So my trapezoidal approximation with the data from this table, my first trapezoid is 1/2 the height of 2, and the bases are going to be 1 and 4. My next trapezoid from 2 to 5, the height is 3, that's my change in x, and the function values 4 and 7. Those represent the length of the bases of that trapezoid. And we repeat for 5 to 6, bases of 7 and 2. And finally, 1/2 of the height of 4, and the bases on that very last one are 2 and 8. And then we'll do the arithmetic order of operations to clean that up and get our trapezoidal approximation. Right, there we go. So punch all that in the calculator, do your work, and you should end up with a trapezoidal approximation of 46. And I believe that wraps it up for part A of the review, and it does.